Howdy folks, I hope you're all doing well. We've just got a bit of general housekeeping for everyone who hasn't seen these slides yet. So like all of these community events, we need to be respectful and kind to others. If you've been harassed or abused, please do report it to one of the DDD team members. If you're on Discord, they're the folks in red. You know, we want to have a safe environment here and just ask that you kindly conduct yourself appropriately. Because the event's not being run in person, DDD are kindly asking folks to donate any amount that they can to support the National Museum of Computing down in Bletchley Park, the place where the Enigma was cracked here in the UK. If you get a chance to go, I highly recommend it. It's a great museum. DDD sponsors this year, helping out with the donations too, seeing as we're all virtual. You'll find all of these folks in the Discord sponsors channel. You know, they're always looking out for great talent to join them. So if you're in need of a change of scenery, feel free to get in touch with one of these sponsors. And then just to wrap things up, it's always awesome to see everyone engage on our socials. So don't forget to get on Twitter, hashtag DDD2021 at Developer Day. And we hope that you've enjoyed your sessions so far, and I hope you enjoy this one too. UI testing is a point of conflict amongst app developers. In a poll asking whether developers actually write them, over 50% don't even bother. But why? We all understand the importance of testing, and many developers will write unit tests or integration tests for backend APIs. So don't you think we should write UI tests too? For anybody that doesn't know me, my name is James Croft. I'm a principal developer and a Microsoft MVP in Windows development at Razer in Sheffield. I've been developing desktop, mobile, and web applications for over 10 years now, and I have a passion for the mystery that's around the edge of coding that we all know as DevOps. That includes improving product delivery, analyzing business needs, building product, testing, and deployment. If you want to hit me up on socials or check out what I do in my spare time, you'll find me on Twitter or on GitHub at James M. Croft. And if you have any questions during the session, please do drop them into the session's Discord channel and we'll get to them. If I've got some time during the session, we might go through some, but I'll try and answer them all over on Discord. So earlier in the year, I was curious if app developers were writing UI tests. So I took to Twitter with a poll for a little insight, as you do. Just a simple question. Do you write automated UI tests for the apps that you build? 3 responses, yes, no, and what's a UI test? I'll drop that last one in as a bit of a joke to see what responses I'd get. Now, what do you all think was the most common answer? It was, in fact, no. So I was a bit curious as to why people weren't writing UI tests, so I asked for a few responses. So let's take a look at some of those. First one on here, missing an I should option. Half of the people that are responding are lying and answering yes because they know that they should write UI tests, and the other half are cringing to hit that no button. You know, this is an individual who's ambitious. They know that they should be writing UI tests, but they're not doing it at the moment. If the poll, if I'd seen this poll show up a year or 2 ago, I'd have definitely been on the I should fence. Now it's a part of my routine. You know, they felt that they took too long to write compared to other types of tests. Understandable. Here we've got someone who previously has the too long to write mindset, but is actively writing them now. Here we've got using Uno UI Test and a combination of Xamarin Ui Test as well with Selenium. So again, someone who is writing tests, you know, they're up to speed with the latest and greatest for cross-platform apps. And then finally on here, I answered no because I don't know how, and they primarily program with UWP. And this is the most common response, that people don't know how to write UI tests. So I wonder how many of you connect with some of these comments. You know, they take too long, not sure how to do it, but you definitely should be. So let's take a look at what UI testing actually is. And funny GIF, it's not something that you get your users to do, even this little dog. At a high level, these are the most common types of UI testing. Types of tests that you can write for software. At the bottom of this pyramid here, we have unit tests. A lot of developers know what a unit test is. It's usually just a small test that verifies a specific part of your application. It might be a method or a class with a specific piece of functionality. Now, these tests might be, as an example, testing your storage abstraction. Make sure that those files are being saved to disk, but it doesn't specifically look at a high-level feature of your application. It's literally just checking that that file is being saved to disk. Now, because of the way that unit tests are written in that way, if you only write unit tests, naturally, you'll write a lot of them, to cover your entire application if you wanted to go that far. And because they're so minute in detail, they can usually be run in parallel. So a unit test doesn't really affect any part of your application, so you can really ramp up running all those tests at the same time. Next up in the list, we have integration tests. Now, these can sometimes go by other names, end-to-end tests. Essentially, an integration test is the next step up from a unit test. In most applications, these run at the API level, and they'll test domain-specific features of your application by calling endpoints and asserting that something has happened. So in that example of the saving to disk, at this point, it might be that a user has called an API which uploads a file to a blob storage, for example, and that file is then returned, the URL to that file is returned. So this type of test here will test that that is happening. It will test that the API gets called correctly, and if you're an authenticated user, you're authenticated. Test that the blob exists in blob storage, and then also test that the response includes that URL. So it does a little bit more. And as naturally, as we're coming up this pyramid, that means that we write fewer of these because we're testing more of the application. And then right at the top of this pyramid, we have UI tests. In simplest terms, a UI test really just checks two things about your application. It checks how your application handles user actions, so things performed via your mouse or keyboard, or if you're using another type of touch input, for example, and whether the visual elements like buttons, links, text, image, and so on are displayed correctly and work as intended. Now, while UI tests don't verify that how your data gets into blob storage or into a database, for example, it tests where your users actually are, the things that they see and visualize within your application. Your users won't know that when they click save that it's committing to a database, because as a user, do they really care? They just need to verify that that data is available, and your UI tests can cover that. And with UI tests, we'll write even less of these, even less than unit, even less than integration. And it's because here we get the most code coverage of your application. And while it might not actually be, as I say, might not be touching that area of code in the test itself, what the UI test is doing is checking the different parts that should happen within an application. So a user, or in this case, I guess an automation, has clicked the button, chosen a file, uploaded the file, and then they can see that that file's uploaded by verifying it in the UI. It doesn't matter what's happened in the background because it's all there visually. Now, each of these types of tests are important in their own right. What I'm not saying is that UI tests should be the only tests you write, because they don't test everything. They just test the majority of your application. So they should coexist. In my opinion, I think that more effort should go into writing UI tests, followed then by integration tests, and then lastly unit tests in that order. You should write fewer but more coverage with UI tests, and then those little niggly things that you can't quite get with a UI test that you really want to verify just to make sure is working correctly. You drop down to the integration test and test at the API layer. And if you really have to, but it should be far and few, write those unit tests to test that little piece at the bottom. UI tests themselves, though, they actually come in multiple flavors. I've talked a little bit here about automated tests, but manual testing is also a key part of UI testing. But you've all heard the phrase like, if it can be automated, then it should be. And this really applies well to UI tests. Let's talk about manual UI testing and what that actually means. So with manual UI testing, a human has the control over functionality within your UI. Now, this works really well for finding visual issues and testing that the user friendliness of your application is on par. This part of testing involves human observation to find any issues, something that can't be properly detected by automated tools. Now, normally, manual testing requires more time to complete. A real person, a tester, needs to prepare a lot of upfront scenarios, get the app in the right state, and then actually execute all of those steps to verify that each of those scenarios is asserted, successfully. That process is slow, and because we are all human, it's prone to human errors. This could easily allow issues to slip through QA and into your users' hands. As an application grows, it can also be quite difficult to test complex scenarios. It increases the time for testing, and this can lead to these most often not being tested or not being tested often enough. That's where we start looking at automation. The bits where, I guess, because we are all human, I don't want to do that. It takes too long. Why, if you were doing a regression of an application, it's really important to test those feature areas. But if you need to get that release out, an automation would speed that process up a lot faster. So on the flip side, automation. First thing I want to point out is how resilient automated testing is. Automated testing is reliable and will always return the same result. So we have scenarios now where we have reproducible assertions for your applications. And because every single step in a UI test is automated, you're not subject to human error like you do with manual testing. In my opinion, an automated UI test suite allows you to better test and monitor the quality of your product. You get that visual feedback, similarly to how you write your API automations. Also, automated UI tests allow you to run all of your tests much more quickly than manual testing. You can quickly simulate complex scenarios and get into parts of the application a lot faster with an automation than you can with someone having to use their keyboard to type, click around with their mouse. And like I said before, unlike humans, your test suite is not going to complain at you when it has to look at these complex scenarios and go, these are going to take too long to run. And it also allows you to then, and this is key, this is really important, it allows you to pivot those testers. In a lot of organizations, the people that run manual tests aren't usually, they're not usually coders, essentially, only because they don't get the chance to do it. And I think a lot of them would really like to get into that space. And this is where automated UI testing is a good opportunity to put your testers into that role, to upskill them in software development and give them those additional skills that then they can apply across your project team. Finally on here, automated testing enables your project team to receive quicker feedback. It benefits the overall productivity of your team across the board and gives more insight into the quality of your application. Any level of automated testing is essential. It will make you get your product out faster with minimal issue with your application, because the automation is validating that for you before it gets out the door. So even though manual testing, I believe, has its role to play, I'd say strive to keep that as small as possible. Manual testing should be limited to just finding those visual issues or a usability issue with your application, because these are things that are hard to test with an automated UI. Automated UI is really around functionality. So what are some of the challenges that people face with UI testing, and why do we see so few people writing them for their own applications? I've got a few more comments to go through that I hear from time to time, both in project teams, on social media, or when I consult with other companies. And maybe some of these will also resonate with you. So here's the first: my UI changes too often. That's understandable. You know, applications evolve over time, and it can often feel like wasted effort to put UI tests in up front. You know, I've worked on so many applications that have had complete refactors of UIs without even revving a major version. You know, these are things that we can put in. There are processes that can be put in place in project teams to make sure that we solve this problem, both in the UI tests as well as part of your DevOps flow. And here's another. Quite a lot of people say this as well. My UI tests take too long to run. Again, a fair point. You know, UI tests are testing your application on a device, potentially an emulator or in a browser. So they'll naturally take longer to run than something closer to, say, unit tests or your integration tests, but they are faster than a human. So, you know, I've worked on projects that have, you know, spent a good hour just running through automated UI tests, but that's testing a really large scale application, and it would take an individual a lot longer to run through all of those tests. You could be talking days or weeks. Writing UI, my team didn't include IDs on inputs. Now, this one usually comes from the testers themselves. It's important to include IDs in your application itself. And the reason for this is that the UI test frameworks need something to latch onto to be able to start interacting with those UI elements. So if we don't include IDs or something unique that we can pick up during the UI tests, it makes it a lot more difficult to write them. So these are just a few things that you can change in your process to get developers to put IDs in, or even, you know, encourage your testers to jump into the code base and put those changes in themselves. This next one I'm going to share with you is probably the most common. And even from personal experience, I do agree with it. You know, writing automated UI tests takes far too long, and over time they become unmaintainable. You know, why should you invest in that when you've got a flow for your API integration and you can churn those out with speed? You know, if it's taken as long to write the UI tests as writing the application itself, is it really worth it? I've heard these comments from clients I've worked with when UI tests are going to cost just as much as another feature, and you know full well that that feature is getting priority over your UI tests, despite you knowing that the UI tests are critical to ensuring quality in your application. So if we skip them, then we're exposing the project and its potential users to issues. So while we're pondering on those challenges, let's have a look at some of the ways that you can write UI tests. And I'll also throw in a demo showing how to tackle some of those challenges as well. So here are a few of the options that are available. Now, this is not the list. It's not exhaustive. You know, there are a lot more frameworks out here, but these are just a few that I've used myself or I'm aware of that people use today. A lot of them have got quite a great community backing. You'll find that a lot of these are actually open source. So we're going to go in row order, left to right. So in the top left-hand corner here, we've got Selenium. This is one of the most popular choices for writing automated tests. It's supported web applications since, I think, early 2000s. It's regularly kept up to date. You know, as browsers technologies change, a lot's changed since 2000. It's completely open source and it supports multiple programming languages. So whether you're a C# developer, JavaScript, you know, it's there and you can bring your own skills into play. Next up, we've got Appium. Appium is a framework that's built on top of Selenium, and you'll find this actually as I go through a lot is built on top of Selenium because it's been around for so long. And Appium itself extends the support for writing UI tests to native applications as well. So when you're writing desktop applications, think Windows and Mac OS, and native mobile applications for Android and iOS as well. These can run on the physical device, just as Selenium can run on your browser. So you can actually plug in your phone to your laptop and run these tests on a physical phone. And there are cloud services as well that allow you to run those tests there as well. Because it's built on top of Selenium as well, you get that broad range of languages. So again, it's just an additional layer that you can write UI tests for cross-platform applications. So now, because you've got the two, because they work in tandem, you can have a big cross-platform application which supports web, mobile, and desktop, and write UI tests which run across them all. Next up on the list in the top right-hand corner is a framework built on top of Selenium called Legerity. Now, this is a framework that's built on top both of Appium and Selenium for writing maintainable UI tests. Essentially, it takes what those two frameworks can do and puts some design patterns in place that make it a lot easier to build UI tests for Windows, Android, iOS, and the web. But it's specifically designed for C# and .NET. So if you're anything like me, it's a great choice. Also simplifies the development, so it brings in element wrappers. Now this is a concept that takes a native UI control, say a drop-down, and puts all of the code in place that allows someone to select a drop-down and select an option. If you were to write that yourself, you'd have to check each part of the UI to get to where you need it to be. Essentially, just taking out some of the effort around interacting with UIs. So you don't have to do any of that boilerplate, essentially. On the next row, bottom left, we've got another that's built on top of Selenium. This is called Protractor. Protractor is built specifically for writing UI tests with the Angular framework. And actually, similar to Legerity, has some built-in extensions for querying UI elements the same way that you might actually write your Angular application. So say, for example, you had a list of items, you can write your UI test to extract that list of items for you and provide that back just by reading the syntax of the UI for an Angular application. So it makes it really easy to write tests for Angular. Next on the bottom row, we've got Smart Bear Test Complete. This is an all-in-one paid IDE. So, this is the one. I think of all of them, this is the only one that's not open and free to use. But it allows you to write automated UI tests without any development experience, which is great for those QA teams that don't code. So they can just drag and drop pieces into a UI and build up their UI test suite without really having to get deep into, say, C# or JavaScript. It can run UI tests on every platform, so desktop, web, and mobile applications. It also has integration, because it's an IDE, it has integrations with all of those sort of modern source control systems, such as DevOps, Jenkins. It can run in your pipelines and do CI as well. One of the clever things that Smart Bear can do is, if you already have a partial test suite written in Selenium, you can also bring those in, so it can run those tests for you as well. And finally, another option here on the bottom right, we have Xamarin Ui Test. Now, Xamarin Ui Test is specifically tailored towards using existing languages. So Xamarin applications are built with C#, so the UI test framework is also built with C#, and it's specifically designed for Android and iOS applications that were built with Xamarin Forms or Xamarin Native. It can also work with native applications, but I would recommend looking at an alternative like Appium, because the way that Xamarin UI Test is set up is, if people are familiar with Xamarin or Xamarin Forms, you write one UI and it works everywhere. So similarly, with the UI testing framework that they've built, it's the same. You write one test and it runs everywhere. But you can achieve that with other frameworks as well. And as I said, these are just a handful of the UI testing frameworks that are available today for you to pick. There are many more options to choose from, especially if you're not familiar with any of these programming languages. So let's jump out of the slides at this point, and I'll give you a quick, I guess, lap around Selenium and how you can write UI tests to solve some of those challenges that we mentioned before. So before we jump into the to the UI tests themselves, here we've got just a really quick to-do application. It allows you to create lists. So we can add a list in here. We can view lists. We can add tasks. We can complete tasks. We can delete tasks. We can edit tasks, etc. It's just a really noddy application, but we're going to write some. I'll show you how we can write UI tests to test the functionality so that I don't have to come into this app every time and follow these steps to make sure that nothing's broken. So I jumped into Rider, and we're going to start at the test fixture itself. Now, test fixture, for those who are not aware, is essentially the thing that runs your UI tests. It's the setup for writing a test. In this specific example, we're using NUnit as the framework, but you can use whatever you like. There's no limit to that. So in this example, we have the ability to test using multiple platforms. So this is a web application. So I might want to test it on Chrome. I might want to test it on Edge. I might want to test it on Firefox. And I, as a writer of UI tests, I can do that. So I can write one set of tests and test them on every platform, and that's what this configuration is here. So part of my base test fixture, I'm going to test on Chrome, and I'm going to test on Edge Chromium as well. As we scroll down, I'll show you some more bits that are a part of this test fixture. The application itself. So when you run a Selenium test, under the hood, there's this application driver or web driver, which is the thing that interacts with your UI. By sending commands to it, essentially. It's a command line tool. The abstraction here allows us to call into that from within the tests themselves. So we have a reference to a static version of that app. Now this can be anything. It can be a web app or a desktop app, but in this instance it's a web app. And we've got some configuration down here. One of the important things that you can do with web applications, and when I show you running the tests in a second, you'll see how this all works, but you can run your UI tests in a headless browser. So if you run that on a desktop, for example, you can just let it run in the background and not actually affect your UI, or you can run it without headless and you'll see the screen pop up and you'll actually start seeing the interactions on the UI itself. And I do apologize, I am looking to the right here, and it's because that's where this screen is. So this is just the setup, and one of the other things that you can do when you're setting up a test is putting together some common interactions. Login, for example, I don't need to do login every single time, but I do need to log in every time to the application, but I don't need to test it. So under the hood, I've got this sort of login implementation here that I can call from my test to log into an application before I start doing something. You might notice some bits in this UI test, which I'll drop into and explain what they mean in a second. But first, let's start at the lowest level. I talked before about these element wrappers. When we look at the application itself, if I get the application back up, on the left-hand side here, we have this tasks sidebar, you could call it, where if I add more task lists in here, you can see that there's same UI, and it's a list. This has interactions. I can add task lists. I can edit tasks within the list, and I can delete tasks as well. So in the tests project, we've created a wrapper for that sidebar. So in here, what you're seeing is a wrapper around what is a Selenium element. So a web element is a Selenium element, or there's a remote web element, which is an actual implementation. Now, because we're creating these wrappers, we want to be able to easily cast to them when we use Selenium's underlying driver querying to retrieve that UI element. So we can convert it directly into a task list sidebar, and I'll show you that in the test in a second. What you're seeing here are those interactions. So the add task list button, it might be easier actually if I get these up side by side. If I minimize that, the add task list button is this button in the top right corner. And if we actually inspect this using the UI inspector, what we see down here, let me just collapse this in, you'll see that this UI element has an ID, add task list button. And we can reference that in our UI tests. So I can find an element on the UI by the ID. So add task list button is the link between these two. So anytime I call add task list button.click, it knows that it's going to find that button and click it for me. And similarly, task list is the task list in this left-hand bar as well. And what you'll see in here are some common interactions, just methods of things that can be done within this context of this element wrapper. So I can add a task list and I can pass a task list name to it. And here you start seeing those interactions with the UI elements themselves. So in order to add a task list, I physically, would have to click the add button. This modal appears. I can set the task list name, and then I can press save, and it adds it to the list. So we're mimicking that in code. So click the button, set the task list name, and save. These are also element wrappers. That's why you can. This doesn't come part of Selenium. So under the hood, we have an element wrapper for the modal too, which again, as you go deeper, you start to see these interactions. But just as you build a UI with reusable components, we're mimicking that same UI structure of your application within the UI test itself. So if I have multiple of these task lists, I can just reference this same thing again and interact with it without having to write that UI test code again to actually interact with the same UI just in a different place. So here are just a few more examples of things you can do. Editing the task list, deleting a task list, selecting one, and verifying. This is really important, verifying that something is visible in the UI. You can do that with Selenium as well. And that's how you do your verifications or your assertions. You can, obviously, because you're using NUnit or a unit testing framework, you can use regular assertions and say this thing should be X and let it run through in a similar way. But you can also use the driver itself to do the validation for you, because under the hood, with Selenium, at least, when you call something and it should happen, the driver will throw an exception, which will then obviously fail your test. So this verify element shown is just going to check using a text, it's going to check every UI element to see if this text exists. So if we go one step further, one of the most important design patterns in UI tests is this page object pattern. And the page object pattern is around building a UI test structure that mimics a page within your application. Now, we've only got one page in this app, it's the home page. But what you'll see in here is reference to those element wrappers. So, as I was showing you, as you can go deeper, at this level, we've got reference to the task list sidebar. We've also got reference to the tasks sidebar, which is the, in this application, the bit on the right. This is all part of the same page. So in our UI tests, we have reference to that within the page itself. And what you'll see here is a common interaction with how UI tests work in the page object pattern. So some of the interactions I can do on the home page get lifted up from the elements into this page itself. So adding a new task list, editing a task list, they're all calling into that underlying element wrapper code. Sometimes you might call more. And what you're seeing in all of these methods is that it's returning the page back. What that allows us to do in the tests is chain our functions together to, I guess, show to a potential person coming into the UI tests what's actually happening in a human readable way. Obviously, you don't have to chain them together. This is just an approach you can take. So here we've just got these common interactions. Now, when we get to the test itself, we write these, or you should write UI tests or any type of tests in a functional way. When something happens, it should do this. It does an assertion. So in my test structure here, I've got this when completing tasks. So when completing tasks is the name of the class, and then each test is an interaction. So when I complete a task, it should move the task to the completed tasks list. So here we've got that common. We all understand how to write unit tests or integration tests. We've got that same logic here, an arrange, an act, and an assert. So here we're just doing some setup. We're creating our page. And under the hood, the application driver for Selenium has already started our app, and it's starting to run this test. The home page then goes, OK, I'm on the home page, is essentially our starting point, because that's what happens when the application loads. I then want to add a new task list, and I want to add a task to the task list. Then I want to perform my action, which is completing the task. And then I can do my assertion, so I can verify that that task has been completed by, under the hood, in those element wrappers, checking that the task is in the completed task list. And if it's not, then throw in an exception. So at a high level, this sort of covers how the UI tests can be then structured. So what you're seeing here is that human readable. We already understand what the functionality is, the feature of the application. So completing tasks should do this. Maybe it's a line of AC. And then when you actually read the test, anybody can come in and understand exactly what's happening here. So from the home page, add a new task list, add a task to it, complete it, verify. And it's really straightforward, really simple and clean code. If something changes in the UI, I don't have to go and change every single test. I can just go change it at the point in the code where that change has happened. So say, for example, in this application, we changed the ID of this button, this task list button. I don't have to go through every single test which interacts with that button and change every test. I can just go into the task list sidebar and say it was the ID that changed. I can just update the ID here, and every test will then go back to passing. And that's where you get that maintainability, by having these separate layers of element wrappers, page objects, and then obviously writing your UI tests in a structured way that allows someone to be able to read it easily. Now, it's obviously great me showing you how to code these tests, but let's take a look at them running. So these might flash up really fast because of the way that UI tests work. So you might not actually see what's happening because once the test is completed and it's asserted, it closes the application and starts again. But just to show you how these actually run. So I'm going to hit run, and I'm going to keep my fingers crossed that these all appear. So what you're seeing now is those interactions, all of those tests that do something with my application. And you'll see a brief flash of the login screen, because we've got that code under the hood that does the login for us. It's just doing that, and then it's starting the test. So each one of these tests is running obviously in the non-headless mode. So I've done this on purpose so that you can actually visually see what's happening. But under the hood, you can change this to run headless. So say, for example, you're running this on a build server, so Azure DevOps or GitHub Actions, for example. What's actually happening here is quite resource intensive, because it's actually loading the UI and clicking around buttons and inputting into fields. When you run in headless mode, you don't get any of that pop up. So essentially, it's just running at network speeds rather than your device itself. And that's really important, because obviously your device could be low powered. I'm okay in this example because my laptop's got an i9 processor and 64 gig of RAM, but on a low powered device or a mobile device, as an example, you might want to run those in a headless mode. So let's jump back into the slides. So that's giving you a little bit of a taster as to what you can do with UI tests. But let's go back to all of those challenges that people were having and just talk through how we can solve some of them. So UI changes too often. There's ways that we can tackle this. Update your team's workflow. Allow UI tests to be created as part of your testing cycle. When a feature is dev complete and ready to be tested, you'd like to ensure that there's no additional structural changes at that point. So in this example, the ability for users to edit a task on a task list. Once we've completed that functionality, we hope to not change it again during this development process. That might be that we've not, if that happens, we might not have structured our stories correctly. So when a feature is dev complete, ready to be tested, the tester can just pick that up and write a UI test, or it can be part of your dev flow. The developers can write UI tests too. And you could even introduce it as part of your PR process, to validate that a user has created, or a developer has created the UI tests as part of their change. Try to reduce major UI overhauls. It's really important to not change your UI as you're developing it, and consider that obviously a major UI change, if it's a design change that completely restructures the UI, that is a major version change in your application, and you will have to work around that to obviously completely change your UI tests. But if you've got it in that structure with the element wrapper, the page object, it's really easy to just go in and change certain parts. Obviously, if the UI changes completely and the user interactions are different, that's a different story. But if it's just moving things around the UI, maybe changing an ID or a class name gets changed, it's easy to go back into your UI tests and restructure them. And all of this brings me on to my last point in here. The abstractions, in the UI test code, each of those layers is really important. Unnecessary changes to your UI tests, it'll reduce the time it takes to actually build a UI test by putting those abstractions in. Tests take too long to run. As I mentioned before, it will be natural. You're running UI tests on physical or emulated devices. There are other challenges to face with a specific device. Is it performant enough? Are there any network issues? If you have a backend infrastructure like the application that I built, if you're not running it locally and you're running it on a CI and it's in a test environment in Azure, your UI test, your application might be able to run, but the backend might be down or whatever. There are those things to consider as well with writing UI tests. And even the queries themselves, if depending on how you write your queries, it could take the test or the driver a long time to actually find the UI element that it's looking for. When it comes to running the tests themselves, what I would say is try to run them on a nightly build or a scheduled nightly run, separate from your main build pipeline, separate from the PR process for the actual build itself. And it's not because these tests are not important, but they do take a long time to run. So if you have a test suite that takes an hour to run, then having that on a PR process will delay your PR from being merged in, for that hour, because it has to wait until the build is completed. So by putting them on nightly runs, you free up your build agents and also free up any of that sort of busier working hours time where people are doing their PRs as well. And finally, just make sure to make your element selectors, and this is across any framework, really specific to the element you want to find. When you do it, things with like IDs, IDs are usually unique, so finding that in a UI is relatively straightforward. Obviously, there are some more advanced scenarios, specifically in the case of Selenium, where you might want to use an XPath query, and XPath queries can be quite complex, but you can also get them very specific to what you're looking for. Inputs without IDs, this is one that you'll build into your team's routine. Whether there's an input, if someone's putting an input into your application, make sure there's an ID on it. Inputs specifically, buttons, text entry, selectors, just make sure that it has an ID on it, because it's just, I guess, a good practice to have. It makes writing the UI tests a lot easier, both for yourself or if you have a test team. I do want to call out the second point. I come back to this, foster a positive environment for your development team, where you can empower your manual testers to get involved and get down into that code base. We're all working on the same project, on the same team. We're aiming to deliver a really high quality product. So we should encourage each other to get involved, make the necessary changes, and not make it a hostile environment for, say, your testers to come in, because they might not be as into coding as developers are. So if you foster that environment and help them to understand the code base and actually get involved and change app code to write their UI tests, that's such a great experience. And ultimately, it allows them to not be blocked. If they're the ones that write the UI tests and your dev team don't have the time because they're building features, well, they've got to wait now or run the manual tests. I mean, they could probably run the manual tests with how long it takes the dev to actually pick it up. So really get them involved. And finally, on this one, where we don't have the opportunity to use IDs, say for a list of items, make sure that we have something else which is really unique, a class name or or some attribute on each of the sub items within a list that we can reference. And then using the element wrapper pattern, we can create this root object, which is detected by an ID, which is the container for the items. And then each of the items underneath we can reference by that other common UI element, UI attribute. Finally, I guess the challenge that most face, it takes too long to write UI tests and they become unmaintainable. I'm going to keep repeating what I guess I've said. Without the right patterns in place, it's always going to be a problem. You're not going to get any better at writing UI tests by repeating what you're doing over and over again. It's the same way you build an application or your API. You wouldn't repeat yourself. So keep everything in a maintainable state by creating the structure of element wrappers and pages, and then your tests really are just calling into those things that you've already created. They shouldn't touch the UI. You shouldn't be doing any selectors within your test itself. It should all be hidden under the hood in a neat way. Look to implement that page object pattern. It's an abstraction that allows you to, I guess, expose those element wrappers for the UI and allow people to interact with your UI without having to write it for every single test. Mimic that with the element wrappers as well. And I guess really importantly, write your test itself in a functional scenario. It improves everything that you've done even further. In most cases, the functional scenarios are the best tests to write for your application, because they're usually tied to a requirement or a feature of your project. So when you write tests in that way, the functional scenarios likely you'll never touch them ever again. Only make small changes to those pages or the underlying element wrappers. So this is just a small taster of what can be done with UI tests, and there's so many other design patterns that are out there. The page object pattern is just one of them. And I honestly believe that if you are building applications that have a UI, you should be including some degree of automated UI testing to complement all that effort that goes into the functional testing that go in your API. The UI of your application is what your users actually interact with. So we need to give them the best experience possible before they even get the product by putting tests in where it's actually most needed. If you've got tests for your API, they will not care if the API has all the code coverage in the world if your UI itself is not functional. Now, you might be asking yourself, what is this QR code for? Good question. That demo that you've seen today, plus a whole variety of useful information, online courses, articles, GitHub repos, all that stuff that to get you started on your journey of writing UI tests is inside there. So feel free to take a screenshot of this, or if you've got your phone, I'll leave it up for a few minutes, snap that and bookmark it. I'll also link it in the Discord channel as well so that people have got access to it. And with that, I'll see if there's any questions. There's any questions in there? Should you write UI tests? Okay. How do you compare Selenium and Playwright? What about issues between snapshots that's semantically the same, but maybe a pixel or two gets shifted around? I've not used Playwright myself. Selenium has been my go-to only because I'm used to using it. I haven't actually had to play with Playwright, I might have a look into it now that you've mentioned it. I'll also include it in my in the resources. In theory, when you reference things by ID, it doesn't matter where on your screen UI elements are, because the UI test itself will be able to pick that up and click the right thing or interact with the right thing. So there are problems in UIs where there might be a UI that's overlaid on top of one another, and your UI test framework usually will tell you that and say this thing is not working. I can't click this because it's being hidden. Some of the other questions in it, I will also put the answers to these in Discord as well. I'm just reading these out just because we've got a little bit of time. When you run Selenium on a less responsive application, elements can take time to render. Selenium offers various wait strategies. Have you got any strategies towards handling these? You mentioned headless state. So you're right, Selenium itself, if people have used Selenium, has this wait function. Now, what you saw when I was running these tests is it was Selenium, but it was actually using parts of that Legerity framework. So the element wrappers, the page object pattern under the hood, they've all been solved within the Legerity framework. So I've included that in here to do that. And that itself has a really useful wait function, which takes advantage of that under the hood. So you can wait, and then it's got these conditions that you can use. So you can wait on a UI element until something has happened. It is useful to use those. A lot of applications can't render the UI very quickly, or as this question mentioned, running it on a mobile phone, it might take a few minutes, or hopefully not a few minutes, but a while to load. And I would suggest when you're writing UI tests and you're finding these problems, these are good opportunities to make improvements to your application, because although there is a little bit of effort involved in how the driver is running your test, it's not really all that much. When things are taking a long time to render, they are problems with your application. If your application isn't responsive, then these are opportunities when you've written a UI test to say, this test actually took a lot longer than it should have. What happened there? And start putting those fixes in place to actually improve your UI. And I think that was all the questions in the chat. So unless there is anything else, I'll let you all join on to your next session. Thank you all for coming. Hope you enjoyed it.